Welcome. So this question says, what is the work done by the varying force during the first 8 meters of this journey? And the force and the motion are on the same axis. So here we have our force, but it changes with position. And here we have our displacement, D. And my work is equal to, well, it's going to be the area under the trace of a force versus displacement graph. So where do I begin and where do I end? It says the first 8 meters. So the first thing to recognize, let's do this in something you can see. So the first thing to recognize is that my journey ends there, my interest ends there. And then the second thing to recognize is that I need to divide this up into convenient shapes. I used to use triangles and rectangles, and now I use, if it's a trapezium, I can work out a trapezium. It's pretty straightforward. It's just another expression. So there's those two. What I can say is that my work done by this force is equal to, well, let's take the trapezium first. It's the average of the heights. So it's 20 plus 30 over 2. Let's just look on our graph. I'm looking at that point there. There's my 20. There's my 30. And I want to kind of average it. I want to take this corner and put it down here and pretend it's a rectangle. So it's the average of the heights multiplied by, by 4. Sorry, no. The average of the heights has a 2 in it. Now I'm going to multiply it by my width. And my width is from 0 to 4, which is 4. Added to, now I'm on the green bit, and it's a rectangle, so it's just, well, the height, which is constant, multiplied by its width, which is 8 minus 4, which is 4. So if I look at this, I'm going to get 50 times 2 is 100, and then 30 times 4 is 120. So my work done is equal to 220 joules. And there we have it.